Bismillahirrahmanirrahim. Okay, for today we continue for conjunctive normal forms. Or we can call it as CNF. Okay, CNF for the definition. CNF is a formula if and only if is considered of conjunction K1 and K2 and until Kn. Okay, this one is the uh, formula. Okay. Okay, please mute your microphone. Okay, siapa tu yang bising tu? Please muted your microphone. Okay, thank you. Okay, basically, conjunctive normal form in Boolean logic formula is conjunctive normal form or clausal normal form. It's the same, clausal normal form. Okay, conjunctive normal form, or we call it as okay. It's a conjunction. So conjunction normally we use the n. Okay, of one or more clauses, where a clauses is a disjunction. Okay, is a disjunction of a literal. Okay. Otherwise, it is a product of some or and or of all. Okay, and then it also a product of some. Or you can have and or all. Okay, clause Ki consists of a disjunction of literals. Okay, basically we have a disjunction. And a literal is a variable. Basically, we have a positive literal or negative variable, negative literals. Okay, no more nesting or other negation are allowed. For this one, okay, if you see uh, no more nesting, okay, they are not allowed nesting, and no other negation allowed. Okay, for example, okay, so far, do you have any question? That's all I got. Okay, for example, we have A, G and C O G. Okay, or we have A or B and C or B. So the clauses may also be literal. uh, A and B, A or B. Okay. Here, so these literals are seen in CNF, conjunctive noun form, as a conjunction of literal clauses and conjunction that happen to have a to have a single clauses. Okay, this one single clauses. Okay, it is possible to convert a statement to CNF that are written in the form other form, such as disjunctive normal form, DNF. Okay. Okay. So far, do you have any question? Ada soalan ke? Okay. Okay. No later. Fifi. UN. Normal form. Okay. Conditional form of proposition is another canonical form that may occasionally be useful, but not the same degree as the disjunctive normal form, DNF. As the name should suggest, after our discussion, the conjunctive normal form is a form of proposition that is equivalent or associative with the concept of conjunction of disjunction. Okay, it easily constructed indirectly using disjunctive normal forms by observing that if you negate a disjunctive normal form, you will get the conjunctive normal form. Okay, for example here, okay, we have a disjunctive normal form because we have negated. Okay, okay, P and negate Q or negate P and negate Q is equivalent to, we open up the negation. Negate P. Okay, this one is okay. Okay, and we get O lah, Q. Okay, and then here O we have N, and then negate is positive P. Here N, okay, will be be O lah, because this one is De Morgan law. Okay, possibly negated and variable called literal. Okay, to convert formula into the CNF, CNF. Okay, and then to convert formula into CNF. Okay, first one, open up the implication to get the or of. Then secondly, get rid of double negation. Okay, we can give you the example. Okay, I give you some of the simple examples. Okay, example we have E is equivalent to negate A or B and C, or is equivalent to negate A or B and negate A or C. Okay, this one is De Morgan law. Okay, and then in general, CNF become quite big. Okay, if we have here, okay, okay, and then okay, continuation of that, we have CNF and DNF. C for conjunctive, D for this distinctive lower form. Okay, CNF is where V over variable negation, literal, okay, and then V of literal is also for clauses. And then for this disjunctive is of, okay, and is of literal is called the term. Okay, here is a variable of their negation, that we call it as or, and then literal is called clauses. Here in conjunctive we call it as clauses. Okay, and then for this one we call it as a term. Okay, clauses and terms. Okay, for example, okay, we you need to differentiate between literal and clauses. Okay, for example, number one, we have x, we get y, z, whereby negate p. Okay, this one clauses or literals. Hafifi Nabila, Hafifi Nabila, negate p, literal or clauses. Is it clauses or term? Sorry, is it clauses or terms? Is it disjunctive or conjunctive? Yeah. Is it the clauses or the terms? Term. Why term? Okay, as you can see here, negate p. Okay, because we have here we have O. It is a clauses of. Okay, we have because we have here. Okay, secondly, okay, we have X and negate Y or Z, whereby negate P are terms. Okay, because we have here. Okay, okay. Fact about CNF and DNF: any propositional formula is tautologically equivalent to some formula in disjunctive normal form. Okay, and then any propositional formula is tautologically equivalent to some formula in normal form. Okay, okay. Please be remember for CNF, CNF take conjunction of negation. ossifying, ossi, ossifying truth assignment, whereby the DNF take this junction of all satisfying truth assignment. Okay, please be remembered here. Okay, and then example we have A or B implies C and D into conjunctive normal form by using the equivalent form theorem. Okay, we have A and B implies C and D. Okay, first we go the implications. Okay, we go by the implication. Negate, we have negation A or B and C and D. And then after that, we go by the De Morgan law. Okay, De Morgan law is to take the negation into the bracket, and then we have negate A and negate B or C and D. After that, we have a distributive law. Okay, first one. Okay, and then we go by second distributive law. Okay, okay, A negate A or C and negate A and or D. Okay, and negate B or C and negate B or D, and then after that we go by the associative law. Okay, so far do you have any question? Okay, so Ashraf baru datang ke? Okay, this one is called equational reasoning. Wait, Okay, another example to reduce the conjunctive normal form for the formulas. Okay, we removing the negation by using the implications. Okay, and then we have solution. Okay, negate P or Q or negate R or negate S. Okay, and then this one we have De Morgan law. Okay, negate P or negate Q or negate R or negate S. And then we remove the negation. Okay, P or negate Q or negate R or negate S. Negation normal form. Okay, we go by the negation normal form. Okay, for the negation normal form is a literal or either proportional variable. Basically, is a negation symbol appear only in the literal. Okay, and then after that we have associative. Uh, we have distribute associative law. Okay, P or negate uh, R or negate S. Okay, here, and then we have this one. Okay, because of associative law. Associative law. We have here. Okay, negate Q or negate R or negate S. Okay, in mathematical logic, a formula in a negation normal form if the negation operator is only applied to variable and the only other allowed Boolean operator are conjunction and disjunction. Okay, for example, another NNF negation normal form. Okay, we have negate P or negate Q, whereby the Q or R and NF because if the negation symbol appear only in literals. Okay, what is literal? Literal tu apa dia? Hmm, apa tu? Tahu dia punya negation. Literal tu apa dia? Dia atomic formula. Okay. Okay, atomic formula that represent a logical value that can either be true or false. Okay, boleh? Okay ke? Okay, basically, literal is appears in conjunctive normal form. Okay, and the method of resolution. Another example. Okay, we have reduced to CNF the formula. Okay, we have negative P implies Q implies Q implies negative R. So we have used the implications. Okay, put the negation here. Okay, and then negative P implies Q or okay Q implies negative R. Okay, then we have the De Morgan law. Okay, negation. Okay, P or Q or negate Q or negate R. Okay, and then we have negation normal forms. Okay, uh, negate P or negate Q. Okay, and then we have negate Q or negate R, and then after that P here, Q here, and then make sure from the conjunctive we go by the disjunctive N. Okay, this one is the associative law. Associative law. Okay, any question? Boleh ke? Okay, later I give you the exercise. For example, okay, number one. Okay, please do this example. I give you 5 minutes, 10 minutes, 10 minutes. Convert the following sentences into the conjunctive normal form. The question. Okay, please use this one. Implication, De Morgan law, associative law, distributive law, and associative law. Okay, boleh? Okay, first one, siapa nak jawab? Latifah ada Latifah. First, siapa nak jawab? Izul Ashraf boleh? Ashraf? Izul Ashraf? Boleh ke? Hazlinda ada Hazlinda. Nur Hazlinda? Tak dengar ke? Izian Hanani ada? Izian Hanani, nombor satu jawapan dia apa? Belum siap lagi. Simple je. Apa yang susah sangat? Normally when you see this one, kita nak ganti dengan apa? Ni. Kan kamu dah belajar dalam discrete math. You have learned in discrete math. Sama dengan ni. Oh. Okay, so first one is solution number one. A. Saya buat lain lah. Surat lain. Macam mana? Exam ni tadi. Nombor satu. Answer dia apa? Okay, dalam kurungan A. Or B. Or C. Kod. Mana ada boleh kod-kod? Tak tahu. Aduh, implication kan dah tengok tadi contoh yang ni. Contoh yang ni, implication apa dia. Jadi, kalau yang ni kamu kena buat macam ni. Implication. Okay. Okay, and then after that, you have A and or B. Kita buat di Morgan Law. Di Morgan Law kamu dah belajar kan? So, A and okay, this one is the answer. Boleh ke? Okay. Ni siapa pula nak jawab? Liana Atika, nombor soalan nombor 2 apa? Nak jawab ke? Liana Atika, ada ke? Atika? Semua tak ada je ni. Gimana? Nurul Izzati? Izzati ada? Apa dia macam mana? Belum buat? Tapi kamu buat apa? Aduh, macam mana macam ni? Jadi jawapan dia apa? Okay, the answer. Kamu tak buat ni. Ke kamu tak faham ni? Negate A or negate B or negate C lah. Okay, this one is the answer lah. Okay, because yang ni satu je. Okay. Yang ketiga, roda dan roda. Okay, and macam mana? Sekejap. Answer. Dalam kurungan. Lepas tu? Ha, E or A or tu je. Mana implicationnya? Ni implication dia mana? Jawapan dia macam ni. Kena ada negation. Negate A or B. Lepas tu kita ada negation kat sini. Negate B. Uh, okay. Jadi for this one, we have for the for the associative law, we have true lah. This one. Kenapa tak ada negate C? Sebab ada O C. Sama. Okay, nombor 4, siapa nak try? Nombor 4, Nurul Syairah ada. Nombor 4 macam mana? Okay, negate B. Macam mana nak buat? Siti Ali dia ada. Macam mana? Answer dia. Apa dia? Negate P, negate P. Okay. Negation, negation P. Lagi. Oh. Okay. P, negate P or Q. Okay lagi. Lepas tu kena ada true lah. True value lah. True. Okay, good. Okay. Okay, boleh. Sekejap, ni bagi contoh lain lah. Okay, we have here. Okay, example, another example. Okay, P, Q, okay, Q, okay, P. Okay, macam mana step dia? Solution dia? Okay, first, negate P or Q implies negate Q. Then number 2, negate P or Q or Q or number 3. And number 3 we have negate P and negate Q. Because this one is we open up the Morgan law or negate Q or negate P. And then we have the associative law P and negate Q or Q or negate P. Okay, and then we have the distributive law. Okay, P and Q in or negate P and negate Q or negate P. Okay, because here P to here, Q to here. This one is we call it as associative law. Associative law. This one is distributive law, distributive and associative. Okay, this one is associative. Okay, okay, this one is distributive. Boleh ke? Tak boleh juga. Izati boleh ke Izati? Okay, siapa lagi yang tak faham? Who else didn't have some basic understanding? Sebagai nampak, nampak, yang nampak sikit je nampak banyak lah. Aduh, ni kamu ni. Saya nampak sikit je. Macam mana nak nampak banyak? Ya saya. Step 5 ni, associative law. Apa yang tak faham yang associative law? Tambah mana? Oh, associative law ni macam ni. Sekejap saya terangkan ya. Okay, associative law. Associative law definition state that when any uh, three real numbers are added or multiplied, then their group or association of the number does not affect the result lah. For example, we have A plus B plus C is equivalent to A plus B plus C. Sama lah macam ni. From distributive law, we have P or Q or negate P lah. Sama je macam ni. Same. This one is we call it associative. Siapa tanya tadi? Siapa tu nama? Aiman, boleh? Boleh nampak? Sikit lagi. Aduh. Contohnya we have 3 multiplied by 5 multiplied by 6 is equivalent to 3 multiplied by 5 multiplied by 6 lah. Kita alihkan dia punya kurungan dia. Or we can have like this, A plus A plus C is equivalent to A plus B plus C, or we can have A B C is equivalent to A B C. Okay. Associative ni maksudnya kita tukar je dia punya ni, dia punya kurungan ni. Okay. Jadi kat sini P and naked Q. P ni kita O ni maksudnya kita darabkan dia. Di P or Q or negative P lah yang ni. Yang ni associative law lah yang first tadi kita buat ni. Okay. Sama je. Yang ni sebab dia panjang sangat, dia daripada from the distributive law, kita nak pendekkan dia, kita pakai associative law lah. Boleh? Okay, for summarization, what we done in a simple way. In a simple way, we can see that first step we remove all implication and okay, and then secondly move negation inside. This one we go by the implication. Remove the negation inside. Use the De Morgan law. Okay. And then use distributive law to get a proper form. Okay, and lastly, associative law. Okay, to simplify. Okay. Okay, this one convert the following formula to CNF using the equivalent transformation. Okay, and then from the formula, okay, we got the transformations. Same, we use the remove all the uh, implications. Using the implications, and then we go by the De Morgan law and associative law. Okay, then okay, to reduce the following formula, we have P implies Q and R. We have here. P or Q implies R, and so on. Okay, please do this one in Padlet for your exercise. Okay, please upload to Padlet. Okay, I give you another example. Saya bagi kamu satu lagi example supaya kamu faham. Okay, we have negation. Okay, negate P or Q or R, P plus Q. Okay, first step apa yang kita kena buat? First step, apa dia? Kita buat implication How to do the implication? Macam mana nak buat? Hafiz. Hafiz, Mama Hafiz. Diam je. Iman. Mama Iman. Okay, first we negate P or Q or R, or we negate P implies Q lah. Okay. Yeah. Okay. Solve for implication lah. So we have number two. We have the De Morgan law. First one is implication. Okay, second is we go by the De Morgan law. Okay, we have negate P here. Kenapa ada negate kat belakang P? Sebab kita nak buat implication, kita nak buang apa? Sebab kalau kita tengok kurungan ni, dia ada dua kurungan, so dia ada satu lagi kat sini. Okay, kita nak buka kurungan ni. Ni. Okay. Okay, then kita negate P or sorry, or Q or R, negate P. Okay, this one is De Morgan. And then number three, we have negate P or negate Q, okay, or negate R, negate P, and negate Q lah. This one also De Morgan law. Okay. Then for the distributive, we have for P or negate R or Q. Okay, this one is distributive. Okay, distributive. Before we get distributive, okay, this one is a shortcut. Before that, you need to have like this. Ini shortcut. Sekejap saya tunjuk satu lagi. After the Morgan law, we have a double negation. We have a P and make it Q, O, make it R, P, and make it Q. And then after that, uh, we have P, and make it Q, O, P, and make it Q, make it R. Okay, and then we have 6 P, and make it Q, make it R. Okay, and then lastly, then P, okay, this one distributive, O, make it R, and make it Q, and this one is distributive. Okay. This one is okay, this one is commutative, based on the based on the associative commutative. This one is item motion. Item pattern, item pattern. Okay, the pattern is the pattern kita we group P and negative Q, or P and negative R, or negative R, kita item pattern. Okay, the pattern is a property of certain operation in mathematical and computer science whereby they can be applied multiple times without changing the result. Okay, boleh? This one is commutative, and item pattern is based on the associative law. Lastly, we go like this for the distributive. Oh, sorry, this one is not commutative. Okay, this one is we name it as double negation. Double negation. Okay, this one is commutative. Okay, this one is idempotent. Okay, lastly, we go by the distributive. Boleh? Ya. Idempotent tadi. Yang mana? Oh, yang ni. Pak ni sama, Pak Cik. Ni sama ni. Sama kan? Sa- Sama dia O kan, O salah satu. Jadi commutative ni kita dapat commutative. Atau idempotent ni kita idempotent ni kalau kamu tengok A plus A is equivalent to A, or A intersect by A is equivalent to A lah. So A union A is equivalent to A, sama je. Jadi kalau ada ni P and negative Q or P and negative Q kan sama kan? Sama tak? Ni dua ni. Sama kan? Jadi idempotent ni dia gabungkan satu je lah. P and negative Q lah. And then okay, and then after that baru kita buat distributive. Maksudnya kita buat P negative R and P and Q or negative R. Okay, this one. Clear? Clear tak? Ke tak clear lagi? Dia sama Kalau kamu tengok ni sama Sebab itu kita buat double negation, and then we have commutative kan. Commutative tu maksudnya kita kita buat yang sama tu dekat depan, and then kita we separate the R here, okay, make it R. Then because this one same. Okay, any question? Ada soalan lain ke? Clear tak? Yeah. Okay, so in your final exam, if this question appear, you should have proper steps that you show step by step. At first implication, and then De Morgan laws. Okay, if you have double negation, and then you can see this one is the same, and then you go by the commutative law. After that, you idempotent. Okay, you combine the same. Okay, same like A plus A equivalent to A, and then after that you go by the distributive law. Okay.